Reference angles, reference angles. This is a video about reference angles. Hi, it's your instructor again, Daniel, on a quick video on reference angles. And be a little careful. These aren't the same as coterminal angles, two angles whose terminal sides exist on top of each other. For example, 30 degrees and 390 degrees, which is 360 plus 30 more, those are coterminal. So you got the initial side, which is always on the x-axis, and then the terminal side. These are reference angles, and I'm going to show you 4 or 5 different ways this semester to find the sine of a 30-degree angle, or maybe the sine of a 150-degree angle. I'm going to show you several ways. There's the finger method, finger guy. If you've ever seen Stand and Deliver, you need to watch that movie. I think the only movie based on AP Calculus. But anyway, Mr. Escalante, did something with multiplication. Well, I can show you how to do it with your fingers on finding the sine and cosine of angles just using 5 digits. It's pretty cool. I'll show you how to do it with the unit circle, which is really cool. But I'm going to first show you how to do it with reference angles and your 2 special right triangles. Because in most trig textbooks and most problems, if you're expected to find the sine, cosine, tangent, or the reciprocals of an angle without using a calculator, usually we're dealing with 0 degrees, 45, 30, and 60, and 90-degree angles, things of that nature, or angles whose reference angles are 0 degrees, 30, 45, 60, and 90. Now, before somebody watches this video and goes, wait a minute, yes, there are other formulas, double angle, half angle formulas that help us find other ones, but really, any basic trig student should be able to find the sine, cosine, tangent of a 45-degree angle, 30 and 60, using special right triangle. You don't even need the unit circle at all. But before we can even get to that, I'm going to help you try to find the trigonometric ratio of any angle. But more importantly, that's another video. That's the very next video I'm going to be shooting. Right now, I just want to talk about reference angles for a few minutes. And it's all about the x-axis. Reference angles, let's get back to the x-axis. So I've got 8 examples up here, and hopefully this will be enough. You'll watch the video because you know you love my smiley, pretty little face, and you'll just want to watch these. So again, watch this video like you're watching something that's good. You fast forward it past the dull parts and you play it over and over and over, like the Karate Kid, you want to fast forward it and then watch the crane kick scene, over and over and over again. Do it with my video. Let's get it on. So 150-degree angle. 150-degree angle in standard position starts here and opens up just like that. Just like that. So what we want to do is say, get back to the x-axis. So 150 degrees reference angle would simply be from 150 to the x-axis, which is 180, 30 degrees. The reference angle to a 150-degree angle is 30 degrees. It's that simple. It's that simple. Oh my gosh. So a 300-degree angle. So right here, and it opens up all the way around. And of course, how many degrees does it take to get back to the x-axis? 60. So there it is right there, 60 degrees. I apologize, my colors are a little off. If this will help you. There we go, and all the way around, blah. So negative 185 degrees. So keep in mind, here we are, we're going clockwise. So 180 is here and up 5 more degrees. So it's just like that. To get back to the x-axis, it is only 5 degrees. That is the reference angle. 765 degrees, oh my gosh. So let's see what that would be. So that's 360 plus another 360 is 720. So 720 from that is 45 degrees. So that is my reference angle, 45 degrees. In other words, where's the terminal side and how many degrees does it take to get back to the x-axis? That's the reference angle. So look at these. Oh my gosh, I've got them written in iterations of pi. Oh no, I'm not good at that. Some students are going to change these to degrees and work them like that. But don't do that. Like this is 0, this is 1 pi. 1 pi radians is 180 degrees. So this would be a half pi. So the question is, where's 3/4 pi in the grand scheme of this? 3/4 is halfway between a half and a whole. And if you're saying, well, that's confusing, then let me do it another way. If this is 1/2, we can also call this one 2/4. There's 1/4. So here's 1/4, 2/4, 3/4. 3/4 pi. So to get back to the x-axis, so here's the angle right there. To get back to the x-axis would be only 1/4 pi. So 1/4 plus 3/4 is 4/4, which is 1 pi. There's your reference angle. It's not that bad. So 7/6 pi. Come on, have fun with this. This is fun. This is real. 7/6 pi is a little bit more than 1 pi. So in other words, our angle would look like this. All the way, that's 1 pi. So 7/6 is 6/6 plus 1/6. That's 7/6. So this is 6/6 pi. Then go a little bit more. That gives us our 7/6. That distance right there was only 1/6 pi. That is our reference angle to get back to the x-axis. 13/6 pi. We could have fun with that one. You're saying, well, what is 13/6 pi? I'm so confused. I can't do radians. Yes, you can. Again, here's our angle. 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, 7/6, 8/6, 9/6, 10/6, 11/6, 12/6, which is 2 pi, 360 degrees. So that's 12/6. Then up here is 13/6. So we went all the way around from 12/6 to 13/6 was 1/6. That is our reference angle once again. And what about 9 pi? Oh my gosh. 1 pi, 2 pi, 3 pi, 4, 5 pi, 6 pi, 7 pi, a few more. That's 8 pi, 9 pi. So 9 pi coincides right here. So this was 2, 4, 6, 8. There's 9 pi right there. Right there, 9 pi. It's on the x-axis. Therefore, its reference angle to get back to the x-axis is 0 radians, 0 degrees, whatever you want to call it. Keep in mind, a reference angle is all about the x-axis. How many degrees does it take to get back to the x-axis? So this one took 30 degrees to get back to it. 150 plus 30 is 180. This one took 5 degrees to get back to it. 5 plus negative 180 is negative 180, or 185, you know what I mean. So 30 and 60, 360. This one right here, this one went past it, so we had to back up again. This one had to get back to the x-axis, back to the x-axis, back to the x-axis. Reference angles, it's all about the x-axis.